So we are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video we'll be discussing the problem of the day for 9th of Feb. The name of the problem is sort by set bit count. Previously this problem hasn't been asked in any companies as I can see the text. But this particular problem is very important for us because it will help us to see another dimension of how we have to sort in terms of the set bits count of a particular number. So you'll be given an array of integers, and what you have to do is basically you have to sort all the numbers by the count of their set bits, right? So please give me a +1 in the chat if everything is there some audio issue from my side? Perfect, let me know. um just give me a minute, I'll check the audio issues. Is the audio coming nice? Okay now, just let me know in the comments. Like normal, because in the previous video also I had some issues like on code error. I think now it's working fine, right? So whenever the audio is a little bit scattered, you can let me know, right? Please give me a +1 in the chat and like the video if you are ready. Okay, right. So let's start with this particular problem. What you will be given is you'll be I'll just okay, let me start. So in this particular problem, what we have to do is we have to sort the numbers by this set bit count, right? In this particular video, in this particular problem, what you'll be given is you'll be given an array. You'll be given an array, and in that array you'll be given some elements, right? You'll be given some elements, and what you have to do with those elements is ultimately in the end what you have to do with those elements is you'll be given the array, you'll be given the elements, and you have to sort the element. You have to sort the elements by the count of set bit, right? By the count of set bit. What is a set bit? Everyone knows what is a set bit. If you don't know, I'll let you know. Like if I have a number, let's say 5, so you have to sort according to the count of the set bits. Let's say if a number is 2, so its binary representation is what? 1 0. So it has one set bit, right? It has one set bit, right? Let's say the number is 5, so in that case its representation is 101, so it will have two set bits, right? If let's say a number is something like a 7, so in that case its representation is 111, so it will have 3 set bits, right? So if I have to sort these numbers in terms of set bit, so first of all 7 would be coming, then 5 would be coming, and then 2 would be coming, right? Is this much part clear to everybody? Is it clear to everyone? I hope that it's clear, right? Now let's discuss some of the more cases that we can discuss, right? Let's say if you had a number that is 8 and if you had a number that is 7, so which number would come first? You will say that maybe 8 should come first because 8 is a larger number, but that is not the case here. Why? Because the representation of 8 is 1 0 0 0, right? So this is 1 2 4 8, so this is the representation, so it is having only one set bit. In 7 what we have 1 1 1, right? That is 1 2 4, so this gives me nothing but 7, right? So in this way what will happen? 7, the number 7 will not come earlier, but 7 is having more bits, right? So it will come to the later part. Like you have to sort it in ascending order of the set bits, right? So 8 would be coming first. Why 8 would be coming first? Because 8 is having only one set bit while 7 is having 3 set bits. Let's say if I had 5 as well, so 5 was having 101, so that means it has 2 set bits. So first of all I'll write 8, then I'll write 5, and then I'll write 7. Why? Because 8 is having one set bit, 5 is having 2 set bits, and 7 is having 3 set bits. Set bit is nothing but the bit which is 1. Please give me a +1 in the chat if this much part of the problem is clear to everybody so that we can move ahead. A quick +1 from your side, a quick acknowledgement in the chat from your side would help. Is this much part clear to everybody? Please like the video if up till now things are clear to you, right? That if I have 8, if I have 7, if I have 5, so I just count whatever the number of set bits are there in a particular number, and then I just simply sort it according to the set bits, right? Is this much part clear to everybody? Is it clear to everyone? I hope that it's clear. Now there could be several ways to do it. There will be basically 2 ways to do it. I'll let you know about both. So there could be approach 1. Let me first of all show you that how the sorting is done, like in this particular example. So if these are the numbers that have been given to you, so you have to sort, you'll be given, and you have to sort in descending order according to the set bits count. So whichever number is having more set bits, you have to take that number first, and then after that other numbers will follow. Like in the case of 7, 5 and 8, 7 is having 3 set bits, 5 is having 1 set bit, and 8 is having only 5 is having 2 set bits, and 8 is having 1 set bit, right? So first of all you write 7, then 5, and then 8. So you have to write in decreasing order of the number of set bits, right? This is what you have to do. Now in this particular problem, the challenge that lies ahead in front of you is how will you do it. So one of the ways to do is that for every number, right, for every number you store the number of set bits, right? So for every number you convert it into its binary representation and you count the number of set bits that are there in that number, right? Basically that means dividing by 2. Like if I have 5, so this will be nothing but mod 2 mod 5 would give me 1, then I will have 2 here, so this will give me 0, this will give me 1, so that means 1 0 1, right? So total 2 set bits are there, so whichever number bits are set, so I'll count them, so there are 2 set bits. So in maybe in map of 2 or in a vector, I can store that what are the number of set bits for that particular number. So if I set it like for 2, I have total number of 2 set bits, right? Then I can say maybe for 7, for a number like 7, I can say there are 3 set bits. Then I can say for a number like 3, there are only 1 set, there is only 2 set bit. For a number like, let's say 8, there is only 1 set bit. In that way I can do, and then I can write a customized my own sorting function, right? What you do is you write this, right? A comma a plus n, sort a comma a plus n comma comparator. So in that comparator, what I'll do is I'll have the first element and the second element, right? I have the first element, let's say first element is x and the second element is y, right? Corresponding 2 pairs of elements if I have. So what I'll do is I'll sort if according to map of x is greater than map of y. Basically what I'm saying, I'll sort it according to a customized comparator that I'll make, and that will be according to the frequency of set bits that is present, right? So is this much part clear to everyone? In that case, if you have numbers like 5, 7 and 8, so in that case it will get sorted according to this pattern. So 7 would be coming first, then 5 will come, and then 8 would come, because 7 is having 1 1 1 3 set bits, 5 is having 2 bits set bits, so this will be 1 0 1, and 8 is having only 1 set bit, so it will be 1 0 0, right? Something like this. Is this much part clear to everyone? Please give me a plus 1 in the chat and like the video if up till now things are clear to all of you, right? And then I can think of proceeding further, right? Shall I proceed further, right? It's clear to Shreya. What about others? I hope that others are also clear with this logic. So this could be one of those logic, right? In that case, you just need to write a comparator function of your own. Now another way to do it could be using the concept of maps directly. What I can do is, let's say approach 2, let me talk about it, right? Let's say I have the approach 2 with me. So what I can do is maybe if you want, I can take some numbers if we have a smaller array. So we have 1 2 3 4 5 6, like if we have these numbers only, that is 1 2 3 4 5 6. So let me draw them: 1, then 2, then 3, then 4, then 5, and then 6. If I have these numbers with me, right? So now I want to represent them, right? So what I can do is I can make a map, and in that map what I can do is, for every map I have a key, right? For every map I have a key and I have a value. So instead of having a value, I can make every map behave like a vector. I can make every map behave like, every key behave like a vector. For every key of the map, I can make it behave like a vector. What do I mean by that? So I can mark my key as the number of set bits, right? I can make my key as the number of set bits, and according to that, whichever number is having that many number of set bits, let's say if I have MP of 2, so MP of 2 would store all those elements. Map of 2 will store map with the key 2, that is map with 2 will store all the elements which are having 2 set bits, right? All the elements which are having 2 set bits, all those elements would get stored. Like in this, maybe I can store elements like you can say 5, I can store all these elements, I can store, right? Maybe I can store 3 as well, all those elements which will be having 2 set bits, because the key value is 2. So 2 means what? 2 set bits. I am saying in the map of 2 I'll store all the elements which are having 2 set bits, right? In that way I can store. So let's try and think what will happen, right? Let's try and do the dry run for this, right? If I have all the elements, that 1 2 3 4 5 and 6, if all these elements are there that I am having. So for 1, can I say it is having only 1 set bit, right? I can represent 1 as nothing but 0 1, right? So I'll say, okay, in the map of 1, I'll write the map correspondingly for everyone so that you can understand. So in the map of 1, I'll say that, okay, 1 is there, right? Then for 2, I can say that 2 can be represented as nothing but 1 0. right? So 2 will also be come in this array, that is this array. I'll push back into this array because 2 is also having only one set bit. Now if I'll talk about 3, so 3 is having how many set bits? 3 is having 2 set bits, right? So because 3 is represented as nothing but 1 1, right? So I'll say okay, so I'll say map of 2 is equal to 3. In map of 2, I'll first of all insert 3, then I'll have the element 4. So 4 is what? 4 is nothing but 1 0 0. 4 is 1 0 0, so I'll store it into the first one because it is having only one set bits, right? So in this way I'll store them into a map. Now what will happen? I have 5, so 5 has how many set bits? 5 has 2 set bits, right? So it is nothing but 1 0 1, so I'll store it. What will happen? What is the set bit here? So the set bit is nothing, the element would be 5. Now I have 6. How many set bits does 6 have? So 6 has nothing but 6 is represented as 1 0 0, like this, right? So 6 also has 2 set bits, 1 1 0. So 6 will be in this particular map. What is this map? This map's key is indicating the count of the set bits, right? The number of set bits that that particular element is having, and that particular map is behaving like a vector for all those. So this particular map of 1 is storing all the elements which are having only one set bit, right? Is this much part clear to everyone? Now I will have a range, right? I will have a maximum and a minimum range. What is this maximum and minimum range? I'll have the, if I keep a track of the maximum set bits that I've seen up till now and the minimum set bits that I've seen up till now, in that way I can do it, right? What I'm saying, so let's say if I had some elements, let's say, what I'm saying is, let's think of a more generalized alphabetical approach so that you can understand a little better. What I'm saying is, let's say if you have map of some, let's say mx is the maximum set bits that you can have. So mx is having, let's say, elements like b and c, right? Let's say you have mx of map of mx minus 1, something like this. So basically max set bit minus 1 is equal to maybe something like x, right? X and y, let's say. Now if you are having something, these things like these, so you'll have the minimum set bits as well, right? In the previous case the maximum set bit was 2 and the minimum set bit for an element was 1, right? So here I'll have minimum set bit as well. Let's say in the minimum set bit I'm having an element such that maybe I can have p and q, right? This way I can have, right? So what I'm saying is, you can iterate, you can have a store, right? You can always store that for a particular number you'll be getting it set bits, so you can always keep a track of the maximum set bit and the minimum set bit. And since you want to return, notice that you want to return in what way? You want to return in decreasing order, right? You want to return in decreasing order. So can I say that you can start a loop for I starts from mx and I is greater equal to mi, right? I is greater equal to mi. So from maximum, first of all I'll print all the elements of the maximum set bit. The maximum set bit is mx, so I'll print first of all its set elements, that is first of all I'll print b and c, then I'll print what? X and y, then I'll print x and y because I'll be moving to this, so my I would get decremented, so I'll print this. Then in this way I'll keep on printing, like let's say if map of mi plus 1 was also present, things like these were present, so it was a, so suppose I'll print a, then I'll print p and q, like this, right? Decreasingly I'll print, first of all I'll print the elements of this, that is maximum set bit, the element which is having most number of set bits, then another. In this way I'll keep on printing, right? If this much part is clear, please write clear or a +1 in the chat, and please like the video if up till now things are clear to all of you. Are things clear to all of you? So suppose I'll print a, then I'll print p and q. Is this much part clear to everybody? Please give me a +1 in the chat. A quick +1 in the chat would help, so that I can understand that you are getting this part, right? That I'll keep a track of the maximum set bits that I've seen up till now, the number which is having maximum set bits and the number which is having minimum set bits. And since I have stored in a map, so first of all I'll start printing from the element from the maximum set bits. So I will start from maximum and I'll print all the elements of the maximum set bit, right, which are having maximum set bits. Then I'll print the second maximum set bit. Then in this way I'll keep on printing, right? This way I'll keep on printing. So let me show you the code part for that particular approach so that you can understand it a little bit more better. What I'm saying is, you'll have a function count set bit, right? In this function what you'll be doing is you'll be counting the number of set bits. What do I mean by that? So you run this function, you have count is equal to 0, you pass a particular number into it, current element into it you will pass, and what you will do is, if this particular element is greater than 0 and it's x mod 2 is equal 1, so that means if x mod 2 is equal 1, so that means that this particular bit is set. So if the current bit is set, so you'll do count plus plus. In the end this function will return that how many number of set bits are there for the particular function, right? Please like the video, all of you can like the video, and please give me a +1 in the chat. please give me a +1 in the chat and like the video, right? What I'm saying is this particular function will count all the set bits that are there in the number, right? This particular function is there to count all the set bits that are there in a particular number, and it can do it, right? Whenever the particular digit that I'm extracting, whenever the remainder is 1, in that case I'll do count plus plus, right? What I'm saying is after that you have a int maximum variable, and that will be keeping the track of the maximum set bits for a particular number. That what is the maximum number of set bits that I have seen in a particular number, and mn is what? Mn is nothing but the minimum set bits that I have seen for a particular number, right? It can be 1, it can be 2, maximum can be anything, right? It can be 32, it can be 30, it can be anything, right? So unordered map, I'll declare a map. What is this map? This map is special because it is a map which is having int and vector int. Like, what is this map? So in this map, what I'm doing is, I'm for all the elements which are having a particular set bit, I'm storing them into a vector, right? I'm storing them into a vector or in a list, right? All those elements which are having the same set bits, all those elements which are having the same number of set bits, I'm storing them into a vector. I'll let you know how I'm doing this, right? So I'll start iterating through the elements. Val is what? Val is giving me the count of the set bits, right? Val is giving me what? Val is giving me the count of the set bits, right? Once I get the count of the set bits for a particular number, so what I'll do is I'll do map of value. That is, map of value is the value is the number of set bits for that particular number. So I'll say map of value, that is for those particular number of set bits I need to insert in that particular map, right? So if let's say value was 4, so I'll insert into 4. That is 4 number of set bits, right? So I'll keep on inserting elements in the same vector that are having 4 number of set bits like this, right? So map of 4 will store all the elements which are having 4 number of set bits. Example I'm telling. So what I'll do, map of value dot pushback array of I. So basically I'm pushing the elements which are having same number of set bits in a particular map value, right? After this map corresponding to a particular key, I'm keeping a track of the maximum set bits, the most number of set bits. Mx is equal to nothing but max of mx comma value. So I'm keeping a track of the maximum set bits that are there and the minimum set bits. Then what I'm doing is I do an index, right? Because I have to return, in the end I have to return the final answer in an array, so I have to return it from the starting. So that's why I'll mark my index as 0. This is the way I have done it. You can do it otherwise as well. What I'm saying is, you start I from maximum, so you'll first of all print all the elements of the maximum set bit, right? All the elements which are having the most number of set bits. Please give me a +1 in the chat if this much part is clear. First of all, you'll print all the elements which are having most number of set bits, right? So if map of count of I, so that means that if for a particular I number of set bits, if you have elements in your vector, if your map of I is having elements in it, if your map of I is having elements in it, if a map of I which is behaving like a vector, if that particular vector of map of I is having elements in it, I is what? I is the number of set bits. So if you are having it, so in that case you will print all its elements one by one. So basically you will store it into an array. So array of index is equal to element, and then you do I++, and this is the way that you have to do it, because you just have to change this original array, right? You just need to change this original array in which you will be returning the answer in sorted order, in decreasing sorting order of count of set bits, right? So what I'm saying, you do it like this. That is the most number of set bits element which is having the most number of set bits. First of all, you store all its value into the array, then you store with the next smallest, with the next smallest, and ultimately you go till the end, right? So your I is decreasing one by one. This is what is happening, and you will need to keep a check that, let's suppose that if the maximum count of set bits is MP of 5, that is 5 is the most count of set bits, so it's not necessary that map of 4 will also exist, right? It's not necessary that map of 4 will also have values, right? It's not necessary that there would be elements which are having 4 set bits. So in that case you need to keep a check, right? That map of count of I, if the map is having some elements or not, right? If that particular map of 4 is having elements, or whether it is an empty vector, right? You need to keep a check on that. If it has elements, then in that case you will keep on pushing it and you will keep on updating your index. In the end you will simply return, because you just have to change this original answer array, right? Is this much part clear to everybody? Please give me a +1 in the chat and like the video as well if this much part is clear to everyone, right? I hope that it's very much clear to all of you. It's very much clear, right? What I'm saying is, like, you'll have a particular number, right? So what I'm saying, you will have map of value, let's say mx is the most number of set bits. Let's say it is having value, let's say b and c, and like, let's say you do not have other values, and let's say another next value that you have is map of mx minus 2, right? And it has the value, let's say x comma y, and let's say after some time you have map of minimum, right? Mi, that is the minimum number of set bits. For that you have elements, let's say p, q and r, like this, right? So what I'm saying is, first, if you have map of mx minus 1? No, you don't have. So that's why you'll need to keep a check of the count. Like if this element is not existing, if there is no element existing which is having this much mx minus 1 number of set bits, so in that case you will not print it, right? You will not update your array. So that's why you will first of all have b, then c, right? First of all you will iterate I is equal to mx. For I is equal to mx, you will store the elements b and c in your array. Then you will decrement your I, so mx minus 1, but mx minus 1 is not existing, it is not having any elements, so that's why you will move to the next. So I is equal to mx minus 2. Then for that you will have x and y, because you are storing all its elements, so x and y. Then you eventually move one by one. So let's suppose that I is equal to mi, and this was that was existing, so that's why you will do pqr as well, and this will get in decreasing order of set bits. This will get printed in the decreasing order. This will get printed in the decreasing order of the set bits, and this is the way that you will do it. First of all, you iterate for the maximum frequency, maximum count of set bits, and you print all those elements that are stored in that particular map, in that particular vector which is having the maximum set bits, then the second largest, third largest, things like this. And you always need to keep a check that whether if mx minus 1 is, you are iterating for I is equal to mx minus 1, but it may happen that mx minus 1 is vector is not storing any element, so in that case you will not do anything, right? So that's why you need to keep a check, and then you just need to print all the elements, and you will keep on updating. Like this is nothing but a of index is equal to the current element of the map, and then you do idx plus plus for storing the next element. Like you store the current element here of the map, and then you move to the next index, so idx plus plus, right? This is what we will be doing, right? If please like the video, because I have tried to explain it in the best possible way. What I've done is, again I'm telling you, like you take the maximum minimum, you store all the value in a map of value. The value is like a particular number of set bits that a particular element has. So you store all the elements which are having the same number of set bits in a particular map value, right? So your map val will behave like a vector. So map of 4 will behave like a vector which is having 4 number of set bits in it, every element which is having 4 number of set bits in it. Map of 3 would behave like a vector which is having all the elements which are having 3 number of set bits, right? And you do simply check that if a particular I is not having, if a particular MP of I is not existing, if it is not having any element, in that case you just will have to skip it. Otherwise, if it is having some elements, so you'll push back all the elements and you'll keep on updating your index. Thanks a lot, Mahesh, for your comments. Thank you, Aryan. Right, I hope that this part was clear to everyone. So if you have any doubts, you can let me know in the comments. Apart from this, we have this channel on Geeks for Geeks. We have this channel that is Code Era. So you can consider to subscribe this channel. You can just go to Google, you can just go to YouTube, you can search Code Space Era, and this channel would come. Also, you can find this channel in the featured channel of this particular channel, Geeks for Geeks Practice. So you can check out this channel. I have taken a lot of sessions here, so maybe that could help. That could be something that could help. You can maybe check out the channel. And thanks a lot for watching, everyone. I'll see you soon in the next live. Till then, take care, stay safe.